So starting with the first question, which is that which compound contains two different elements with identical oxidation states. So two different elements with identical oxidation states. My hunch is it's the first one because it's H is plus one. Cl we don't know, that's X. O is minus two. The total charge, it's a neutral molecule, should be equal to zero. And if you do that, X would come out to be plus one as well. So two of the elements in the first option are going to be plus one. So both of them are plus one. So it's going to be the first one. Mg over A is 2 plus, O is minus 2, H is plus 1, so all of them are different. N is plus 1, S is plus 6, O is minus 2, they're all different. And the same is true for this one, H is plus 1, Cl is minus 1. N, I think, is minus 3 over here. As the next one, for the element sulfur, which pair of ionization energies has the largest difference between them? Now, sulfur is in group 6. So if you, so sulfur has 6 electrons in its outer shell. So that's 1, 2, 3, 4, 5, and 6. So where would the jump occur?
D.
6 and 7.
It's going to be D. That once you've removed all the 6 outer valence electrons, then there's going to be a drastic increase in ionization energies because the next electrons are going to be removed from an inner shell which is less shielded and is closer to the nucleus. So the seventh is going to be really difficult to remove compared to the sixth one. Next is which ion has both more electrons than protons and more protons than neutrons. If it says more electrons than protons, that means a negative ion. So we're basically looking at negative ion. So that's forget this one. Uh, and let's have a look at the rest are all true for this first statement. What we just need to look for now is more protons than neutrons. So just calculate the protons. Oxygen is how many protons? It's 8 protons, and hydrogen is 1 proton. It's definitely it's 1 proton, and how many neutrons? That's the same. It has 8 neutrons, and hydrogen has hydrogen has 0 neutrons. The normal hydrogen atom that has 0 neutrons. So that's the number of protons, and that's the number of neutrons. So he was asking for more protons than neutrons, so it's going to be D. What species contains the smallest number of electrons? So you can just go and figure this out. 5 electrons, so that would be 2 electrons left for this. B is 4 electrons, that's also 2 electrons. H is 1 electron, minus 1 means 2 electrons. Helium is 2 electrons, plus 1 means just 1 electron. So D would be the correct option for this one. The next question is about they've shown the activation energy. It's an exothermic reaction, which means all of them are exothermic. So the enthalpy change is from the reactants to the product. So that is delta H. So this one is incorrect. Uh, 1 second, let me add people. I said now this one, the delta H is correct. It's from reactants to products. The activation energy is wrong. The activation energy should, I mean, all of your arrows, they should start from the reactants. Okay, that's your starting point. So it's probably going to be D. That enthalpy change would be from the reactants to the products. That's the net energy change. And activation energy is that you start at the reactants and you go all the way to the top. That's your activation energy. So that's the correct option. Next is which series series shows the molecules in order of increasing bond angles. Uh, CH4 is tetrahedral, TK, which is this one. So the angles over there are 109.5. Uh, BF3 is fan shaped because it only has 3 bonds. So it's fan shaped. and the angles are 120 degrees. And you have NH3. NH3 is derived from a tetrahedral shape, except that on the top they are lone pairs instead of an actual bond. So basically, there is no top. So it's going to be trigonal pyramidal, and the angle would be 107 degrees instead of the 109.5 in a tetrahedral shape because of the extra repulsion from the lone pair. So that's definitely incorrect because the last one has a smaller bond angle. BF3 is 120. CO2 is 180. CO2 is completely linear. It has just two pairs of bonds, one over here, one double bond over here. So that's 180 degrees. So that's and water has a shape that's also derived from a tetrahedral shape, except that on two sides, instead of actually a bond, they're lone pairs. So it's a bent shape, and the angle is 104 degrees. So that's also not correct. 104, 180, 120. That's not increasing. NH3, uh, it probably looks to be C. NH3 is 107. CH4 is 109.5, and CO2 is 180 degrees. So I've already shared you all the all the bond angles and the shapes. Let me just quickly revise what the shapes of the molecules are. Okay, there was something over here. Just one second. This one. So we'll just quickly go through the shapes once more. So remember, two pairs of bonds, that's 180 degrees linear. Three bond pairs, that's fan shaped, and it has two different arrangements. One is you would have three bonds, that's 120 degrees. The other one is you're going to have two bonds, and on one side there's going to be a lone pair. So the shape is going to be bent, and the angle would be slightly less than 120, 117 to 119. Tetrahedral, if it has all four bonds, that's tetrahedral, 109.5. If it has three bonds and on one side there's a lone pair, then it's going to be pyramidal and it's going to be 107. And the water molecule, if it has two bonds and on two sides they're lone pairs, so that's 104.5 degrees. The extra repulsion from lone pairs would keep the bonds closer together. Then you have shapes with five bonds. That's like a fan in the middle with a bond on top and a bond at the bottom. So this is trigonal bipyramidal. Ignore most of these shapes. Then you have six bonds, that's octahedral. And in that shape, you have a square pyramidal shape if you have one lone pair. If you have two lone pairs, that's going to be square planar. Okay? So these are all the shapes of the molecules. Okay? Is this clear up till here? Bazar, is this clear?
Yes, sir.
ठीक है, now, what is the volume of steam produced when 1 gram of ice is heated to 323 degrees centigrade at a pressure of 101 kilopascals? This is a question of PV is equal to nRT. So the pressure is given. So that's 101. It should be in pascals, so that should be 101,000. The volume is not given. So I think they're asking for the volume. N is moles. You can find the moles. How do you find the moles? That's mass divided by mR. Ice is 18. R is 8.31. And the temperature is given 323 centigrade. It should be in Kelvins. So add 273 to it. And you can find the volume. So divide this whole thing by 101,000. Does anyone have a calculator?
The answer is C.
What is the volume that you're getting? What is the volume that you're getting?
0 point volume.
नहीं,
20.
इसका क्या आंसर है?
इसी को बता रहा हूँ. Volume is 2.7 decimeter cube.
नहीं, it's 2.7 meter cube. Remember that. PV is equal to nRT gives the
Nee, I've converted that.
अच्छा
I've
you've already
converted that.
you've
Yes.
already converted that ठीक है चलो ठीक है then it's 2.7 dm cube. Remember PV0 NRT, the volume is actually in meter cube. You have to convert it, and to convert a meter cube into dm cube, you would have to multiply by 1000. So next is solid carbon dioxide is similar to solid iodine in its structure and properties. Carbon is in group 14. Silica is in group 4. Uh, Group 14. Silica is a group 14 compound. Which statement about CO2 and solid SiO2 is correct? Both solids exist in a lattice structure. CO2 is a simple molecular structure. I mean, it's separate molecules that really have not much to do with each other. Weak van der Waals forces. SiO2 is a giant covalent structure. So that's a lattice structure. That's a regular arrangement of particles where each silicon atom is bonded to oxygen atoms and oxygen atoms are further bonded to silicon atoms. So both don't have a lattice structure, both don't have a molecular structure. This one has a lattice structure, this one has a simple molecular structure. So both solids have atoms joined by covalent compounds. That is true. Both solids change spontaneously. Silica does not change into a gas. Carbon dioxide does. Carbon dioxide is a gas actually.
But carbon dioxide में the C double bond O bonds are not single covalent bonds.
Huh, they're not. Both solids have atoms joined by single covalent bonds. ठीक है, he's talking about single. So that's not true. Achha, both solids have a simple molecular structure. Both solids exist in a lattice structure. Achha, he's talking about solid CO2. Okay, this is wrong because of being single covalent bonds. Both solids have simple molecular structure, which is not true. Okay, that's a giant covalent structure. But since the first statement is correct, okay, since they are solids and solids have a lattice structure, he's talking about solid carbon dioxide. If you solidify carbon dioxide, then these attractive forces would be relatively, and there would be a regular arrangement of particles. Okay, so I'm pretty sure it's going to be A. Because all the other, I mean, they don't spontaneously change into gas. That's definitely incorrect. This is definitely incorrect because it's single covalent bonds, not single covalent bonds. Having simple molecular structure, that's definitely incorrect because silica is giant covalent. So the only one left is A, because in solid state, everything is going to have a lattice structure. It's not carbon dioxide is not going to be in gaseous state. The intermolecular forces and carbon dioxide needs to be solidified at a very low temperature. So it's going to be A. TK, is this clear?
Yes.
Yes, sir.
So next is an article. If it is lighter than a feather, stronger than steel, yet incredibly flexible, more conductive than copper, which form of carbon is being described? Does anyone know which form of carbon is?
Graphene.
ठीक है, it is graphene because it's one of the it's one of the strongest substances according to its relative to its weight. A sheet of graphene, and it's flexible as well. Graphite is not. I mean, graphene is a single sheet of graphite, but it's like the example of a copy. The copy is not very flexible. A book is not very flexible. You can't really bend the pages because all the pages are stacked together. But if you take out a single sheet, the single sheet is very flexible. Plus, it's stronger than steel, and relative to its weight, it's very strong. And obviously, it's very light because it's a single sheet. Fullerenes, diamond doesn't conduct electricity, and fullerene is the ball-like structure, uh, which has no strength at all because the ball-like structure is they're completely independent of each other. Uh, so they're not even attracted to each other very strongly. So next one is which one is the enthalpy of atomization of chlorine? Enthalpy of atomization of chlorine. 1 mole of chlorine atoms are formed. So 1 and 2 might be correct from its element, and the element has to be in its standard state. So it's going to be A because chlorine, the standard state, room temperature state is gaseous. So 1 mole of chlorine atoms is going to be formed from its elements. Now the next one is in this is about Kc. So you have a reaction going on where H2 and I2 are reacting to produce 2HI. To figure out Kc and to solve a question like this, you need the initial moles. The initial moles that are given, that are provided, are that the 2 moles of hydrogen and 3 moles of iodine are heated together. So that's 2 moles. And you have 3 moles of iodine, and I don't think that there is any HI. So no HI initially. So that's 0 moles. Then equilibrium moles. You're basically looking for equilibrium moles, and they've given us that at equilibrium there were 2.4 moles of iodine. So at equilibrium you had 2.4 moles of you had 2.4 moles of iodine, and you need to figure out the moles of all the other substances at equilibrium. So if initially you added 3 moles, and at equilibrium, after some time at equilibrium, you're getting 2.4 moles. That means zero point 0.6 moles are missing, and that means zero point 0.6 moles must have reacted. Okay, that's why they're missing. That you added 3 moles, and now you have 2.4 moles. So what you're going to do is zero point 0.6 got reacted. So 1 reacts with 1. So if zero point 0.6 of iodine are reacting, zero point 0.6 moles of H2 would also react. So starting with 2 moles, zero point 0.6 got reacted. So you're left at equilibrium with 1.4 moles. And if zero point 0.6 are reacting with zero point 0.6, तो आगे जाके they're going to produce 2 moles, which is 1:1:2. So it's 0.6, zero point 0.6 reacting to produce 1.2 moles. So on the other side, 1.2 moles must have gotten produced. Which means at equilibrium you have 1.2 moles of this substance. Because initially you had 0 moles. So is this clear to everyone? Abba, Rida, is this clear? Hiba, is this clear?
It's clear.
Yes, sir.
Achha, so the final thing is you have to find the value of Kc. Kc is going to be products over reactants. And remember, they've also given you the volume of the container, which is 1 dm cube. So in the expression for Kc, you use concentration. So it's going to be moles over volume, which is going to give you the same thing. So HI concentration would be squared. So it's going to be 1.2 squared divided by 1.4 and multiplied by 2.4. It's going to be HI concentration products over reactants. So what is the answer that you're getting?
C.
So it's C. Now, next one is, there's the 3 consecutive elements in period 3. Element Y has the highest first ionization energy and the lowest melting point. So across period 3, what happens to ionization energies? Group 1 has the lowest. You move to the right. At group 3, there's going to be a dip, then 4, then 5, then at 6, there's going to be another dip, then there's going to be 7 and 8. So this is your period 3. That what happens in period 3 is that moving to the right, why do the ionization energies keep on increasing? Because they have the same number of shells. Everything is the same, except that there is more and more protons across the period, uh, and they increase. So there's more attraction. So it becomes more difficult to actually remove electrons. So ionization energy keeps on increasing, except for dips at 3 and 6. Why is there a dip at 3? Because of the orbital. All of a sudden, you're removing electrons from a p orbital, which is further away, compared to the s orbital over here, or s subshell over here. And why is there a dip over here? Because all of a sudden, you're removing electron from a p subshell that is paired, and there is spin pair repulsion. Over here, you had a p subshell that was not paired. Every orbital had 1 electron, so there was no repulsion. But now one of the orbital has two electrons, which is why there is repulsion, mutual repulsion. I say, anyways, the question is that three consecutive elements X, Y, and Z. The middle one has the highest ionization energy. So you have a couple of options. The middle one has the highest. It's either going to be this one or it's going to be this one. It's either X, Y, and Z, and the middle one has the highest ionization energy, or it's X, Y, and Z. So you have two candidates. He's saying they're in period three, and the middle one has the highest ionization energy, but at the same time, it has the lowest melting point. So on top of this, I'm going to sketch the melting point. So on top of this, I'm going to sketch the melting point across period three. So sodium has a low melting point. All of a sudden, magnesium has a high melting point. Then you have aluminium, which has a slightly higher melting point. Then you have silicon, which is a giant covalent structure, very high melting point. And then you have what comes after that. That's phosphorus. So there's going to be a big dip, low melting point. Then there's going to be sulfur. Then there's going to be chlorine, and then there's going to be argon. So so that's how the melting points change. Metals, they have high melting points. Silicon giant covalent has a very high melting point. So it's going to be Y because they're saying that Y has the lowest melting point out of the three. So X, Y, and Z. So Y has the lowest melting point. So it's going to be these three elements, which is going to be uh, what is this one? Aluminium. This is going to be
D.
silicon.
Phosphorus and sulfur.
Okay, so it's going to be D. Okay, is this clear?
Yes.
So now the next one is when dealing with the spillage of metallic sodium, it is important that no toxic or flammable products are formed. Uh, which material should be used if there is spillage of metallic sodium? Uh, these three are wrong because he had specifically stated that nothing flammable product should be formed. Sodium with acid would produce hydrogen gas. Sodium with water would definitely produce hydrogen gas. And remember, alcohols, they were very weakly acidic. They would also react with sodium, but very, very slightly. And they would produce a salt, and H2 gas would be produced. The H in the OH would get knocked out by the sodium. So that would also happen in this case as well. So you're left with sand. In sand, no flammable product would be formed, no hydrogen gas would be formed. And the next one is chlorine gas is widely used to treat contaminated water with species present in water when chlorine gas has been added. It is responsible for killing of bacteria. When you add chlorine, this is again a reaction that I've written down in the notes. It's Cl2 with water would produce two acids. One is going to be HCl and the other one is going to be HOCl. So the ion that's responsible for for killing bacteria is the OCl minus one ion. Okay, that's the one that's responsible for this is the hydrolysis of chlorine by water. Which one of the table is correct? Ammonia molecule, it's pyramidal. I mean, it's derived from a tetrahedral shape, except that on one side there is no atom attached. Instead, there's a lone pair. So it's, I mean, basically there's nothing on the top. There's no atom attached on the top. So it's a pyramidal shape. The ammonium ion is when there's a dative bond formed. When an ammonia molecule, so you have an ammonia molecule and the lone pair attracts the H plus one ion and they datively bond and now it has four bonds. So that's regular tetrahedral. So bonds present. Uh, there's no pi bond, there's no double bond. So that's definitely incorrect. So it's going to be A. All of them are single bonds. All single bonds are sigma bonds. TK, is this clear? Zaib, is this clear? Mohammed, is this clear? Yeah, can you hear me?
Yes.
Okay. So, okay. So the next question is hydrogen chloride gas and hydrogen iodide gas have different thermal stabilities. The difference is due to difference in the energies of some of the covalent bonds that are involved in the decomposition. Which row? Now remember, small atoms they make stronger bonds always. Small atoms they always make stronger bonds. So HCl is a very strong bond compared to HI because HI is a bigger bond. There's less orbital overlap. The bond length is very large, and I'm talking about HI. The iodine atom is too shielded to attract the electron from the hydrogen atom. Iodine already has 53 electrons, so it's not going to attract the H electron that strongly. So which one is more stable? HCl is going to be more stable. That's more stable. So it's going to be A or B. And the explanation for the difference in stability is that the HCl bond is stronger than the HI bond. So it's going to be B. As next is there's ammonium sulfate and ammonium nitrate, uh, and they use as fertilizers. These salts have different percentages by mass of nitrogen. They have the same effect as each other on the pH of neutral soil. Which row is correct? So higher percentage by mass of nitrogen. I mean, you can calculate this, or you can simply make an intelligent guess. I think it's this one. Okay, you can go and calculate this, but my hunch is it's this one because there's less oxygen and there's no sulfur. These are big atoms. They're four oxygens. So definitely more nitrogen compared to the other atoms. So that's probably going to have a higher percentage. I mean, you can do the calculation, do the math, just to confirm. Um, and then they're saying they have the same effect as each other on the pH of neutral soil. So what effect would that be? Uh, so the pH, what effect would they have? So they have NH4 plus one ions. ठीक है, they have NH4 plus one ions. Now NH4 plus one ions are capable of losing H plus one ions. So they are the ammonium ion is acidic. It's capable of behaving as an acid, but a very weak acid. So the effect on the pH of the soil, you have two options. One is increase, the other one is decrease. So since they're acidic, it's going to be decreased. It's going to be A.
Sir, but ammonium nitrates have, matlab, they actually neutralize acidic soil. So acidic soils would be like they would increase.
Ammonium. First thing, ammonium nitrate never does that. Lime or limestone neutralizes acidic soil.
Ah, yes, ठीक, got it.
ठीक है? So calcium hydroxide or calcium carbonate. Their problem is that they actually react with lime, and that's the reason they react with lime because calcium oxide is a base, and if you add an ammonium salt, what happens is you get an acid-base reaction because the ammonium ion would produce an H plus one ion, which would go and react with the O over there to form water, and ammonia gas would be released, and you would probably get a calcium salt. ठीक है? If it's ammonium nitrate, you're going to get calcium nitrate, which is why ammonia gas is produced when an ammonium compound reacts with a base. ठीक है, Brad, is this clear?
Yes, I got it.
So next is river water in a chalky agriculture area contains these ions. Such water is treated by adding a calculated quantity of calcium hydroxide. What will be precipitated from the river water? A precipitate is something that's insoluble. So it's going to be B. I mean, we can simply ignore the question because nitrates are all soluble, so they're never going to form a precipitate. Nitrate again, all nitrates. TK, remember solubility table. All nitrates are soluble. So nothing insoluble. I mean, they're not going to be insoluble. Chlorides are are all soluble as well. Uh, Chlorides are soluble because there are only two that are not soluble. One is silver, the other one is lead, and you can add mercury to it as well. So, the rest are never going to form a precipitate. Okay, so we can forget how calcium carbonate is forming. As long as it's insoluble, that's the only one that's capable of forming a precipitate, of forming something that's insoluble. Now you have this question, and they're asking that there's this reaction happening that a black and white photographic film has been developed. An unreacted silver bromide is removed by the reaction with sodium thiosulfate. And they're asking what is the function of the thiosulfate ion? This question, I don't know why it's here. It's an A2 question actually. Uh, but remember one thing about this one. It's this thing, the thing that's written in square brackets. Uh, that is what happens when a metal ion becomes soluble. Uh, I told you, I must have told you about this that if you dissolve NaCl, uh, it becomes NaCl aqueous, and the crystal dissociates. Na plus one aqueous are formed, and Cl minus one aqueous are formed. And I also told you that Na plus one aqueous is not just an ion that's roaming around in water. What it's actually doing is that it's attracting water molecules. Water molecules have these lone pairs which have a very strong partial negative charge. So water molecules would be very strongly attracted to the lone pairs would be very strongly attracted to these sodium ions from all sides, and they end up forming complexes. So these things that you write in square brackets, they are complexes. So Na would actually be in the form of not 2 plus 1 plus. Okay, this is something that sometimes appears in AS questions, but it's mostly because you don't have complexes in your syllabus at the moment. Uh, but just to be on the safe side, always remember metal ions, when you dissolve them, they form complexes. And that's one of the reasons why they get dissolved in water. Why the ions get dissolved in water, because they're not just roaming around, they're actually, the water molecules are actually combined with it, they're sticking to it. Okay, like the complexes that I'm going to show right now, for example, it's like if you dissolve copper 2 in a solution, so if you dissolve copper 2 in a solution, not this. With water, let's. So this is what it's going to look like. That, I mean, let's say this is the general. This is a more general example. A metal ion in a solution is not just going to be existing as a single ion. It would be attracting the solvent molecules around it, and that is what's going to keep it dissolved. Otherwise, it's going to combine with the negative ion that's around, and it would form the crystal back again. So this is why NaCl remains dissolved, because it gets surrounded by water molecules. Is this clear? Ethan, is this clear? Mohammed, is this clear?
Yeah.
Um, because there's a negative ion always roaming around, and that is what keeps them away from each other. And that is why if you dissolve NaCl, NaCl remains dissolved unless you get rid of these water molecules. You have to evaporate the solution, you have to get rid of the water molecules. That's when precipitation happens. That's when crystallization happens, because the positive ion, metal ion, would no longer be surrounded uh, by these water molecules. So the answer to this particular question was that you see square brackets, that's a complex. and that indicates that thiosulfate are making it soluble. Uh, the silver ions over here are combining with the thiosulfate ions, and they're getting dissolved because of the thiosulfate ions. As anyways, the next question is, people who take statin drugs to control the blood cholesterol may have to take this particular enzyme. Now you're getting organic questions. Uh, Now the diagram shows a simple structure of one atom of this enzyme. Which row describes this structure correctly? Uh, Now there's an n. There's an n written over here, which probably indicates that this structure is getting repeated a number of times. Like, I mean, the same thing is repeating over and over again, so it's a very long chain. Which row correctly describes this structure? The enzyme is an aldehyde. It's definitely not an aldehyde because the double bond over here, it's in the middle of the chain. So that's a carbonyl compound and it's a ketone. So it's either going to be C or D. It's not an aldehyde. And the number of pi bonds, how many pi bonds in one molecule? So there's a pi bond over here, but that's getting repeated n number of times. It's getting repeated over and over again. So there are n pi bonds over here. And then you have the total number of pi bonds. So there's one over here, one over here, one. So there are four more pi bonds. Okay, so there's a double bond over here, double bond between the carbon atoms, two over here, and there's one over here. So in total, you have four n plus four. So it's going to be D. Okay, is this clear as well? ठीक है, Minahil, is
Yes,
this clear?
sir.
Yes, sir.
Acha. So next one, there's the two molecules. What type of isomerism is shown over here? So they're forming isomers. Now, uh, now the first thing is there are two types of isomers. One is the two broad separation of isomerism is they are structural isomers and they are stereoisomers. In structural isomers, the bonding is exactly the same. And if you look over here, the bonding looks to be exactly the same. Like in structural isomers, the structure has to be different. The structures are not different. They're exactly the same. Connectivity is exactly the same. Double bond, so there's a double bond over here. CH2, 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 everything is the same. There's a carbon with CH3, then a double bond, then carbon, and that carbon is connected to a CH2OH. And that carbon is also connected to a CH2OH over here. So they have exactly the same structure, exactly the same connectivity. Except, so that means they're stereoisomers. The only difference is that over here, the CH2OH is pointing upwards. Over here, the CH2OH is pointing downwards. That's the only difference. And that's your cis and trans arrangement. Uh, so it's a geometrical isomer. Over here, in this double bond, cis and trans are not possible because even if you switch the two sides, they're going to remain exactly the same. Over here, cis and trans arrangements would be possible. You would have two different arrangements around the double bond. One would be cis, the other one would be trans. So it's a geometrical isomer. Abba, is this clear? Rida, Hiba, is this clear?
Yes.
So next is a section showing two repeat units of an addition polymer is shown. So this is an addition polymer. What is the identity of the monomer that produced this polymer? So this is a section. What is getting repeated over and over again? I think this part is getting repeated over and over again. What you just do is uh, draw the repeat unit. There's a CH3 on top and a CH3 over here and a Cl over here and another CH3 over here. Uh, there were continuation bonds on both sides. What you can do is you can simply get rid of the continuation bonds and put a double bond back inside. So that's your starting point. And now you have to name this. You have to give the name of this monomer. Figure out the longest chain. The longest chain is going to be this one. It's going to start here. It's a bent chain. So that's the longest chain. That's four carbon atoms, which means it's butane Actually, there's a double bond, so that's butene. So it's butene, and the double bond is on the carbon from the second. Like if I start counting from this side, so it's one, and then there's two. So this one is butene, and that would make this B because that's the only one where the main chain is butene. In the other ones, it's either hexane or it's pentoene or methyl butane. The main chain is butene. Okay, is this clear as well?
Yes, sir.
So this one is a butene, and that's it. And chlorine is on the second carbon atom, and CH3 is on the third carbon atom. If you start counting from this side, so one, two, and three. So it's 2 chloro 3-methyl butene. Now the next one is you're given a molecule of butene 1,4-diol, which is this one, and you're forming this molecule over here. So what could be the reagent for step one? Now step one is this is oxidation happening. So the alcohol part is not an issue. You have alcohols over here, primary alcohols. They're going to change into carboxylic acid. So that's probably going to happen in this step. But the middle part is changing into a ketone. If you look at the middle part, you need a CO over here. So that means what type of alcohol? What type of alcohol changes into a ketone? It's a secondary alcohol. What you're going to do is you're going to add water to this uh, between the double bonds. So double bonds over here in the middle, H and OH are going to get added, and then on this side there's CH2OH, and on this side as well there is so there is CH2OH as well. So in the middle you needed an OH group because if it gets oxidized, this one is a secondary alcohol. Remember, primary alcohols. If you revise that, primary alcohols they change into aldehydes and then they change into carboxylic acids. Eventually, they're going to change into carboxylic acids. Secondary alcohols, the ones where the carbon is bonded to two carbon chains, that changes into a ketone. And tertiary alcohols, they don't get oxidized in the first place. So, so this secondary alcohol would at the end of the day change into a ketone. This primary alcohol, they would change into carboxylic acid. So the middle would have a ketone. So the first step is adding water. How do you add water? You add steam. Okay, that's water, and you add an acid catalyst. I mean, there are other conditions as well. There's 60 atmosphere pressure is used, 300 degrees centigrade temperature is used. Uh, so this one is the closest to the conditions of hydration. Okay, you can change an alkene to an alcohol. And they're asking for X, so that is exactly what X is. You're going to get an OH in the middle. Okay, is this clear?
Yes, sir.
So next is 24, which is hydrogen bromide can be added to T to give compound U. Compound U can be hydrolyzed to compound V. So T, and he's saying HBr is getting added. So now you have, on one carbon atom, Br gets added, on the other one, H gets added. So that's an addition reaction. And then he's saying compound U can be hydrolyzed to compound. So the Br gets, it's a halogenoalkane. The carbon over here is partial positive. So if you add a nucleophile like OH minus one, the nucleophile is going to get attracted to the carbon positive, and the Br would take away the electrons and would get knocked out. So it's a nucleophilic substitution reaction. Remember, halogenoalkanes, they undergo nucleophilic substitution reactions. Now, four students W, X, Y, and Z made the following statement: all the atoms in a molecule compound T lie in the same plane. In compound T, all the atoms lie in the same plane. They definitely don't lie in the same plane because carbon over here is tetrahedral. Carbon over here is also tetrahedral. Now, in a tetrahedral arrangement, the carbons or the atoms are not lying in the same plane. One is coming out of the board, the other one is going into the board, so they're not lying in the same plane. So the first statement is definitely incorrect because the shape is tetrahedral. The next one is compound V contains only one chiral carbon atom. So let's look at V, and this is definitely chiral because all four groups are different. But then again, this is also chiral because there's going to be one H which is not shown. So all four groups are going to be different. This side is different. This side is different. This side is different. Something else appears on this side, and this side is also different. So in this molecule, there are actually two chiral carbon atoms. These are not going to be chiral because they have two hydrogen atoms attached to it. So to be chiral, you need four different groups or four different sides. So compound V does not have one chiral; it actually has two chiral carbon atoms. ठीक है? Abba, is this clear? Ethan, Mohammed, is this clear?
Yeah.
Yes.
Okay, so W and X are both wrong. Let's look at Y. Step one is an electrophilic addition reaction, which is true because all alkene reactions are electrophilic addition reactions, so that's true. What happens in electrophilic addition reaction? You need to know the mechanism as well. That if there's a double bond, and I can draw the mechanism just for revision, an HBr molecule would come in. The H is positive, the Br is partial negative. The H would be attracted to the electrons in the double bond, and the electrons in the Br would in the bond with the Br would get repelled because of the electron density in the double bond, and a carbocation would be formed. Because one of the H is going to borrow electrons. So the H would borrow electrons from the pi electron cloud and bond with one of the carbon atoms. The other carbon atom would become electron deficient because its bond is gone because H took it. And then Br minus 1 is going to come and bond with the other carbon atom. So this is an electrophilic addition reaction. So that's true. And step 2 is a nucleophilic substitution reaction. That's also true. Uh, in halogenoalkanes, you had SN1 and SN2 mechanisms. There were actually three nucleophiles that could attack the halogenoalkane. You had NH3, you had Cn minus 1. Three separate nucleophiles could attack the carbon positive, and they could knock out the bromine or the halogen that's attached. And there was SN1 and S2 mechanism. In this case, it's a tertiary halogenoalkane, so it's an SN1 mechanism where the Br would get knocked out first, and then the OH and the NH3 or the Cn would get attached. So Y and Z are both correct. So next is question 25. Structural isomers and stereoisomers should be considered in answering the following question. Let me open the organic. One second. I said this one. Structural isomers and stereoisomerism should be considered following the in answering these questions. Compound is J is reacted with KOH in ethanol. Now this was a reaction of halogenoalkane. It was an elimination reaction. In elimination reaction, bromine is going to get knocked out, and a double bond would uh, form. The H would get knocked out from the neighboring carbon atom. So an alkene would be formed. The same happens over here. Now he's saying that three isomeric alkenes with the molecular formula C4H8 are formed. The answer to that is B. Like if you if you look at this molecule, the Br is over here. The Br is going to get knocked out. Now the double bond is either going to form to the right or it's going to form to the left. So there are two options. One is the double bond forms in this on this side. The other one is the double bond forms on the other side. Okay, so the Br gets knocked out and the H might get knocked from the right side or from the left side. So you have two possible isomers or two possible alkenes that are possible. And the thing is that this particular alkene, which is over here, this is H and this is three H's. This would exist in two forms. One is cis and the other one is trans. It's capable of forming geometric isomers. So there's one molecule of this, and there are two versions of this molecule. So in total, you have three isomers. So three isomeric alkenes are going to be formed in option B. ठीक है, Bhaskar, is this clear? Ethan, Mirail, is this clear?
Yes, sir.
Yes.
So for the rest, you will always have just one alkene. For example, Br gets knocked out. If it's at the end, the double bond would appear over here, and it won't even show cis trans isomer. So that's just one alkene. Br gets knocked out over here, and the H gets knocked from the neighboring carbon atom, and you're going to get an alkene over here. It's going to be the same alkene because all three CH3s are the same. And so now you have this molecule. Which row correctly shows a primary, secondary, and tertiary alcohol? So uh, primary is when the carbon is with two hydrogens and one carbon chain. So this is primary. This one is also primary. Let me focus on this carbon atom. This one is also primary, and all of them they appear to be primary. So pretty much all of them are primary. What about a secondary alcohol? This is incorrect because this one is primary. This one is tertiary. Uh, both of them are primary. This is secondary. That it's going to have two carbon chains. So you're only left with the third one is going to be this one, a tertiary alcohol. Then you have this molecule. The fragrance of compounds in perfumes are dissolved in solvent Y, which has a molecular formula. Um, I mean, this is the molecular formula. The fragrance of compounds of perfumes are often dissolved in solvent Y. Okay, this is not solvent Y, which has a molecular formula C7H12O4. It is made by reacting propane 1,2-diol, which is this one, with ethanoic acid in the presence of an acid catalyst. So you're basically making an ester, an alcohol reacting with a with ethanoic acid, and that's how you're getting Y. And they've given us the molecular formula. They've provided us with the molecular formula of Y, and we need to figure out the structure of Y. So an ester would be formed. Ethanoic acid. What is ethanoic acid? It's double bond O, NOH, and there is CH3. How is an ester formed? H and OH would be lost in the middle, and they would link up. So is that seven carbon atoms? So that's one, two, three, and four and five. That's not seven carbon atoms. You're looking for seven carbon atoms. C7, H12, and O4. So even after forming an ester, we're not getting seven carbon atoms. So that means there's another alcohol. That means there might be another carboxylic acid. The OH is going to get knocked out, the H is going to get knocked out, and they're going to connect with each other. Now, do you have seven carbon atoms? That's one, two, three, four, five, and six and seven. You can count the oxygens. That's four, one over here, one over here, one over here, and one over here. And you can count the hydrogens. So this is the correct molecule. And I think it's going to be B. Is it B, CH3, C double bond O? It looks like B. What's the difference between? It's not. It's not. It's not B. The O is over here, and the serial bond O is over here. So it's probably D. ठीक है, the correct answer is D. The molecule matches D. CH3 serial bond O. So it's CH3 serial bond O. And on this side, it's also CH3 serial bond O. And then you have the ester. So it's D. Next is which mixture could be used to produce propyl methanoate? So that's an ester as well. How do you propyl is 3 carbon atoms, and that's the alcohol side. Methanoate is the other side, and that is 1 carbon atom, which is already there. So this is CH2, CH2. Break the ester. This is going to be the carboxylic acid side. And this other side would be your alcohol side. It's going to be propan 1 all. So it's going to be C. ठीक है, is this clear? Rida, Eba, is this clear?
Yes,
Bhaskar, is this clear? Achha, so which statement about polychloroethene is correct? So what's polychloroethene? Chloroethene is double bond H. So that's ethene. Chloroethene is 1Cl. How does it form a polymer? That the same thing starts connecting with other molecules, and the double bond in the middle turns into a single bond, and that's N. So that's polychloroethene. So it's saying the polymer can be cracked to produce chlorinated alkenes, which might be true. The polymer has the polymer has harmless combustion products. They're not going to be harmless because it has chlorine. It could form HCl gas. Lots of different chlorine oxides can be produced. So it's going to produce a lot of harmful products. Polymer is readily biodegradable. Alkenes, polyalkenes, uh, or any addition polymer, they are not biodegradable because the carbon chain is usually very non-polar. And if you have a carbon chain, a non-polar carbon chain, it's not going to attract a lot of molecules, and it won't break easily. Remember, carbon chains are very, very stable. So not biodegradable. The repeat unit of the polymer has an MR of 97. So we can measure the MR, which in no way looks like 97. It's 2 carbon atoms. That's 24. Plus there's 1Cl, which is 35.5. Plus there are 3 hydrogens. That's no way close to 37. So the first one looks correct, that you can break this polymer like this long chain, and you're going to get alkenes which contain chlorine because there is already chlorine in the chain. So the first one is your right answer. Then you have which way in the table correctly describes the increasing number of carbon atoms. So you can just that's an easy question as well. You can just figure out that's eth, that's 2 carbon atoms. That's meth, that's 1 carbon atom. Meth is 1 carbon atom. Prop is 3 carbon atoms. Pent is 5 carbon atoms, and the other side is also pent. That's 5 carbon atoms. Prop and bute, that's 3 and 4. So that's not increasing number. This is 10 carbon atoms. This is 7 carbon atoms. That's not increasing. So you can just figure out which one has increasing. We can skip this question. The next one is which molecule has an overall dipole moment? The first one definitely does. Carbon monoxide. The oxygen is pretty electronegative. So that side would be partial negative. This side would be partial positive. So there would be a dipole. Phosphine definitely has a dipole because of its shape as well. It's pyramidal and it has a lone pair on top. And P is electronegative, so it's going to pull the electrons closer to it. So it's going to have a partial negative charge, whereas the H are slightly electropositive, so they would have a partial positive charge. Carbon dioxide has no dipole. It cancels out because of the shape. because it's a linear molecule and the dipoles or the attractive forces, they cancel out. Next one is you're given a set of reaction. I think we probably did this, or maybe we didn't do this. Hess law is that moving from one point to the other point, it doesn't matter which path is taken. The enthalpy change would be the same as long as you're making the same thing. So the transformation U to R, you start at U and you want to go to R. So the path that you're going to select is this one. So it's going to be minus 92 because you're going to go in the opposite direction. And then it's going to be plus 134. And that I think would give you 42. And then you have the transformation which is T to S. So how do you go from T to S? You go from this direction. So it's going to be minus 75. And you would have to change this direction. That's going to be minus 92. So it's not going to be endothermic, it's going to be exothermic. 2 is wrong, the third one is also incorrect. Okay, is this clear? So next is, which statement about reversible reactions are correct? A reversible reaction is you're moving from reactants to products, right? So if you have a higher concentration of reactants, you increase the concentration of reactants, where would the equilibrium shift? The equilibrium would try to make more products. Okay, it's going to try and make more products, and so this is probably the last question we're going to do. So it would increase the concentration of the product. And increase in temperature always increases the rate at which the equilibrium. If you increase temperature, the rate, this has nothing to do with equilibrium, the rate increases. That's doesn't really matter whether it's the forward or the backward reaction, it's going to increase. And increase in temperature always increases the concentration of the product at equilibrium. That's not true. Because it favors the endothermic reaction, and it could be the forward, it could be the backward, we don't know. So the concentration of the product might decrease, or the concentration of the product might increase. We're not sure. That depends on the equilibrium. Which side is going to be favored? Then we'll continue with this paper, and we're going to start another paper tomorrow. Then, okay?
Allah Hafiz. Thank you, sir.
Thank you.
Okay.
Okay, then take care. Take care, Hafiz.
Allah, sir.
Hafiz.
Sir.